This is a BMW crown wheel. They weld them onto the standard carriers. Dad's machined it off, ground it square. Now he's machining a part so you can hold it around the other way in the jaws.
You fucking all bread. Anyway, just anyway, got a little bit of chatter, it don't really matter. We'll still the whole thing through. Now. Must be just the chatter's happening. We can get rid of that chatter if we want. We'll have to turn our compressor on now too, won't we?
Yeah, alright. Just wanted to film it. I'll just pause it and go do that.
And film this.
Just turning the air compressor on. You want to buy that hoist? $5 grand. Made in Tasmania. Big, massive truck hoist. All the parts are over there for it. It's all in pieces. $5 grand. Tasmanian truck hoist. It's for sale.
Anyway, that's all right. So, drawers of ½ inch long, see?
Okay.
We should be okay. Now it's just a matter of getting rid of the excess metal. You reckon it was a right offset carrier he's given you for this one?
Yes, it is.
Check it, did you?
Yes.
Yeah. The other one's a smaller buffet.
Yes, it is.
Programs.
One of the seals in the box is all dented a bit on the OD. I just throw them in. Can't bubble wrap them or put them in the box after I've sent them 10 emails telling them.
That's right.
They just can't do what you tell them to do.
Nah. Too big a radius, they can feel it pushing off. And,
Oh, really?
pushes off.
I'm gonna have to plunge it in, won't you?
Well, what we can do again, just machine. We can machine much deeper, that's all. That's all you fucking do. Machine a bit deeper and then it won't fucking be touching any radius. These teeth will be touching the jaws.
Yes. still doing it.
Well, we'll just have to go a bit deeper again. Yeah, another half would be right. Yeah, it'll be right. Okay.
Okay, I'll have to go get that, won't I? See the thing I printed? Pause this. That was a parcel. I wonder what's in it, eh? From fucking Amazon. What did I buy from Amazon? Jeez, I can't remember now. What could it be? I'll open that in a minute.
Just touch this one out, just above where you were.
What degrees did you put it on?
45.
45 degrees.
The radius in the carriers, not all that big the radius is in those steel carriers. So the next trick is you put it on the grinder and grind the last little bit. Under here. Might as well give us a little bit of a dressing. The diameter of the wheel is high. So, industrial diamond.
Put the blocks in there so it holds on the magnet better. Grinding it square. No.
Grind it more if we, well, we don't have to unbolt it, we'll bolt it straight up. Look at area. So, you've got the air on, you reckon?
Yeah.
We'll go over to the machining centre that I trained you on. And show you how to do this. Hello. Now, we've got a fixture here which saves a lot of clocking up. So, nip the nuts.
The on button. The other on button. So what you do is with this fixture, holds it down, and also you get a tool that comes in there and centers it so you know where the center is, so you don't have to clock it up. So it's on. So what we do is we go 0 return, position, all. We go 0 return that way, and then we 0 return the Y, and then we 0 return the Z. Come down, and it goes up, turn the light on. See? 0 turn X, Y, now the Z. We're not using the 4th axis. We've taken that off. There's the 4th axis over there. Don't need that. It's only for when you're drilling. You bolt something onto the 4th axis and it rotates, 5 degrees, 10 degrees. We don't need that for this. Then we go manual data input, program, tool 10, ender block insert, M6, ender block insert. And that, once we hit start, we'll take it to tool 10, which is the plug. There's tool 10. Then we wrap it down. And across. And over. Now, the Y for the T slot we've worked out as minus 261.1. So we go position, all, Y, handle, 261. 200, I just noticed that this screen refresh rate is looking a bit funny on this camera. 261.1. 261.1. 261.1. So now we just have to go Z, come across, Z, bring that over here. We just have to put that. Trying to do all this with one hand so I can film. See that? There we go. Now that's in there, we can tighten up these, and this is the 0 position. It's like clocking it up without having to clock it up. Where's the spanners here? Got this from Bunnings Warehouse. It is a 24mm spanner. Tighten that. Tighten that. It usually lives there. So you see that? That still turns in there, you see? So now, that position there, 304, 304, 372. Go to offsets, X minus 304.372. And input, 304, 372. 304, 372. 304, 372. Just double checking. 304, 372. 304, 372. So it's the same. 261.1, 261.1, 304, 372. So it's correct. So we go home the Z. And now that's clocked up. All I have to do now is set the tool height and run the program. See, it clamps it down with the bolts, can't be moved, and it clocks it up with the hole because that fits in there neatly. So now the program, BMW crown wheel, tool 1 is a 12mm M mill. So we go manual data input, tool 1 ender block insert, M6 ender block insert. There we go. We rapid down. I've already done all that. Right. So we just got to get a piece of paper. I don't know how I'm going to do this with holding the camera. Put the piece of paper there. Handle Z. Let's come down. I'm doing it one-handed here. Gotta bear with me, guys. One-handed. I just turn the phone off by pushing the button accidentally. One-handed, so this is taking a lot longer than normal. Oh, it's getting close. Getting real close. One, going down 0.1. See, there it is there. So that position all 477.3. So we go offset Z minus 477.3. Oh look, 477.4. See, it was the same as the last one we did. 477.3. That'll do. 0, return the Z. So once that's 0 returned, which we wait for it, 0 returned. So we can go memory, program, that's the program, start. And just so there's no mistakes, we can stop for a sec. We can go single block, check, there's the program, run each single block, so it'll go and stops there. It stops at 15 above the job, and the next one will go 0.5 above the job. So we push it 0.5 above the job, and then push it again. We're pushing start, push it again, and that's it. So now it's doing each line, and that line, then that line, then that line. This is doing a 2mm deep counter bore. So when the tap comes, there's no hardened steel because this is case hardened. So you got to get rid of the case hardened. So when it does a 2mm deep counter bore, then it does the 13mm hole, and then the tap comes and taps it. If you don't do the counter bore, the tap fucks up because it's cutting into hardened steel. program. We go check. Distance to go. Feed rate is 30 millimeters a minute. The spindle is 650 revs. Spindle load. When it starts cutting, you'll see the actual spindle load. It just stopped a second ago. So it's starting to cut. I can hear it. Ready right now. %, which is good. You get up to about 20%, you fuck the cutter. So instead of watching nothing, I'll get you back on when it's doing the next tool. I thought I could show you while I'm waiting for the next program to start. Here is the quaife LSD, the BMW rear diff. That is the quaife LSD. We just fit it there. We put the bearings on. The bearings are in there with its circlips they have. That's a design to hold them in. And you put it in without the crown wheel to see the bearing preload. You don't have much preload on these ball bearings. They can't handle much. You need to spin it. It needs to rotate like that. Nice and smooth. That's the correct preload. You can't have too much preload with these ball bearings. Like tapered roller bearings, most diffs have tapered roller bearings like this, you see. That's a tapered roller bearing. You can have heaps of preload on that. But with these ball bearings that they decided to use, you have too much preload and they fuck up. It's the same with the pinion bearings. The bearings in here are ball bearings, double row and double row. Ball bearings. It's absolute joke. Absolute joke what they do these days. Shit bearings. So we get the, there we are, finished, you see. See the counter bore? Get rid of the case hardening. So now we go next tool. Now single block so it doesn't blow up. Right. So that 12mm is going like this, and like a thread. So it's going down, but it's also going like this. So a 12mm M-mill cuts a 13mm hole. But the M-mill's not doing that. The table, this table is rotating around. I wonder if you can see it if I do this. Not really, it's moving such a small amount you can't see it. But if you look up here, you see how Z's going down, Z is up and down, and then X and Y is moving 1/2 mil each side. So that just went to the bottom, now it's going to come up, go to the next hole. So, there's all the movements it's doing. That line's running that, and it's going to do that, that, that. I go the full program, we go check. Spindle's doing 1,800, 28 millimeters a minute. The spindle load is 6, 8. Oh, it's getting up to 10, even 11 I saw before. This end mill's getting a bit worn, I think. It's amazing how long they last. Instead of spending 80 to 100 bucks on one simple end mill, I buy them from AliExpress. Carbide end mills. Look at this one. It's a long one, isn't it? You get them for like 20 bucks. See? There's some more. There's some more in there. That's a 10 mil, that one. Look at these tools I got. Chamfering tool. Hey, here's another end mill. I didn't realise I had that. Jesus Christ. That is 12 mil by 150 long. That's a long cunt, isn't it? I've got all 12 mils in there. They're all brand new. Here's some more 12 mil. There's a long one. Well, we got 12 mil up here. See? We got this the other day, this box of end mills. These ones are from the place up the road. Carby tool. Oh shit, you can't even see, sorry. Carby tools. It's a big end mill. It'll be worth heaps, that. Anyway, I'll get you back on once it's almost finished and you can watch the tapping. So, it's almost done. Let's blow away all that swarf. So it's doing the last hole and it's gone to full depth. So that'll come up in a sec and get the tapping tool. So up it comes. Got single optional stop on, so it'll stop there. See, that's the 12mm carbide end mill. Right, so we cleared out all the holes, you see, 13mm hole, ready to tap, put a thread in there. So we go run the next part, comes around, gets the tap, comes down to 15 above the job. That's 15 above the job. And then it taps. So there's one thread done. This is called rigid tapping. So, it just has the positions. Next one's going to be Y23.64. Then it comes down, they're just all positions. That's that hole, that hole, that hole, that hole. Spindle's at 100, and because it's a 1mm pitch, we're doing 100 millimeters a minute. You see, if you get the speed or the feed rate wrong, the tap will explode, because that tap is a 1mm pitch. It's a 14mm by 1mm pitch threaded tap. And if you have the spindle going, say, 200 and the feed rate going 100, it will just blow the tap up, because it's trying to tap a different pitch. So with rigid tapping, you have to get the correct feed and speeds for what tap you're using. This is a 1mm pitch, so it's quite simple. 100 spindle speed and 100 millimeters a minute. 1mm pitch, 100 and 100. And that's it. It's finished. Now I'll just blow it off so you can see. So there's the tap. And here's the crown wheel. See the thread? And that's finished. Now we bolt it to the BMW quaife LSD. Set up the backlash. And it's over.